A-Level Biology 9700 Paper 4 Variant 2 May June 2025, and in this video we will discuss the question number 9, and question number 9 is the biodiversity of an area can be assessed using a variety of sampling methods. So outline how a frame quadrate could be used to assess the biodiversity of the plants in a field. Now in this question we have to write down the different points by which we can make use of frame quadrate to assess the biodiversity of the plants in a field. For this purpose, first of all, I would want to explain this method. That is, for this purpose, the random sampling setup can be used. And for this purpose, we can place two long tape pairs at right angle to each other along the edges of the field to create a coordinate system like X and Y axis. You can see in this way, in this way. So we can make use of them. Then we can use a random sampling generator to select pairs of coordinates. And then we can place the frame quadrate at the intersections of the randomly generated coordinates. Then we can collect the data inside the quadrate. And for this purpose, we have to identify the species which are present inside. So for them, we can use a field guide or identification key to name the different plant species which are present inside the quadrate. Then we can simply count how many different species are present in the quadrate. Then we can estimate the percentage of the area inside the quadrate is covered by each species. And then we can repeat the process many times to ensure the data is reliable and representative. And then we can calculate the average number of species or percentage cover per quadrate. So in this way, we can estimate for the whole field. So for this purpose, we are moving towards the answer, which I have told you. Now we will start from the first step. That is, first of all, we have to use this random sampling method. To at right angle to each other. Along the edges of field. The random number generator to select pairs of coordinates. Pairs of coordinates. And then place the frame. Frame quadrate is made up of wood mostly. Quadrate at the intersections randomly generated coordinates. Use one identification identification key to name plants, species, present inside the frame quadrate. Count how many different species present inside. Estimate percentage and repeat the process many times and calculate the mean. So it was all about the answer. You can write in this way. Now the next question, part B. A student investigated whether the height of the soft rush plant, Juncus effusus, decreases with an increase in altitude on a hillside in the United Kingdom. 12 sites were chosen at increasing altitudes. The mean height of 10 plants were calculated at each altitude. So 10 plants. So Spearman's rank correlation was used to assess the relationship between the height of the plants and altitude. The equation for Spearman's rank correlation is, this is the formula for that, which we have to calculate. So capital D, key for symbols, capital D, difference in the rank between each pair of measurements. So, and number of pairs of items in the sample, and E B squared summation sign. So this is the sigma summation sign was calculated to be 550. So they have given the value of summation D square. So calculate the sphere ranks correlation for this data. give your answer to 3 decimal places. So here in this case, you can see that they have given 12 sites were used for this purpose. And for 12 sites, the number is 12. And for D, they have used the 550. So make use of these two values. We have to find out the Spearman's rank correlation. So for this purpose, we will moving in this way. I will show you how to calculate the value with this formula. So we will start right from here. RS is equal to 1 minus 6 multiplied by summations d square over n value type. So in this way. So we will put the values over here. 6 multiplied by 550 divided by 12 raised to power 3 and minus 12. So after calculation, it is equal to 1 minus 3300 divided by 1728 minus 12. So we will move in the next line in this way. So it is RS is equal to 1 minus 3300 divided by 1716. I have calculated this value with the help of calculator. So it is equal to 1. After dividing 3300 with 1716, it is equal to 1 1 minus. So it is 1.923. So after subtraction, 1 minus 1.9. So it is equal to minus 0.923. So this is the Spearman's correlation, which we have calculated with the help of the given formula. And we have to write the 3 decimal points. Now we will move towards the next question, and next question is the null hypothesis for the investigation is there is no correlation between the altitude and the height of the soft rush plants. So table 9.1 shows the critical values for Spearman's rank correlation. So the table 9.1 shows the different critical values for 10, 12, and 14. For 10, it is 0.564, for 12, 0.54, 504, and for 14, it is 0.459. So we have to use the value of the Spearman's rank correlation and table 9.1 to state and explain if the null hypothesis is correct. So the calculated value, which we had calculated in the previous question, it was 0.923, which is greater than this value, which is 0.504. So if it is greater, then we will reject the hypothesis. So because we can write, because 0.93, which was the calculated value, is larger than the 0.504, which has been given in this table, which is the critical value for this. So the calculated value. So we can see that we will reject the hypothesis. No, hypothesis is not correct. Null hypothesis. It should be rejected because the it is greater than is the calculated value of Spearman Spearman's Spearman's rank correlation is greater than the critical value 0.54 at the is equal to 0.05 significant level. It means there is less than 5% probability. That it occurred by chance. So it was all about question number 9. Please like, share, and subscribe my channel to watch more videos on the papers. And thanks for watching.